Hello everyone, in this video I'm going to discuss the example for limits and continuity. The function g is defined by the gx, where we have to illustrate the situation in the real number line. The function gx, where we have 0, so x less than 0, so very obvious, on the left hand side we have the x squared plus with the 2x plus with the 5. Continue, x greater equals to 0, so we have 3 multiplied with the exponent x plus with the h. Find the limits when x approaching 0 from the left for the function gx. So refers to the real number line, we have x squared plus with the 2x plus with the 5. So limit when x approaching 0 from the right. We have the function 3 multiplied with the exponent x plus with the h. So focus on the left hand side. If we substitute 0, and we will have 5. So on the right hand side, if we substitute 0, and we will have 3 plus with the h. So that is the limit when x approaching 0 from the left and 0 from the right. And determine the value of h such that the function g is continuous at x equals to 0. So when they mention x equals to 0 is continuous, so meaning that limit when x approaching 0 from the left, where we have the function gx, is equals to limit when x approaching 0 from the right for the function gx. So are the same because continuous. So we have 5, which is equals to 3 plus with the h. So h is equals to 2. Next, evaluate when the limit when x approaching negative infinity for the function x minus 5 over square root of 4x squared plus with the 3. So if we substitute into the situation, so where we will have the negative infinity over the positive infinity, where we have the function id f. So what we have to do is to dividing the numerator and also the denominator by the highest power of x for the denominator. So as we can see in here, we have the situation modulus of x, which is equals to square root of x squared, which is equals to, we have the definition, x negative x, x greater equals to 0, x less than 0. So illustrate, we have 0, on the left we have negative x, on the right we have x. So limit when x approaching negative infinity, so we have to factor out the x. Here we have 1 minus 5 over x. So over, we have the square root, so x squared, factor out the x squared, so we have 4 plus with the 3 over x squared. Rewrite the situation, limit when x approaching negative infinity, so we have the x multiplied with 1 minus 5 over x, over, we have the square root of x squared multiplied with the square root of 4 plus with the 3 over x squared. So kindly focus on this part where we have the square root of x squared. So actually is the modulus of x. So based on the definition, we have the negative infinity, so means that towards the left. So limit when x approaching negative infinity, so we have x multiplied with 1 minus 5 over x, over, we have the negative x, because x approaching negative infinity, so we have the square root 4 plus with the 3 over x squared. Simplify. So limit when x approaching negative infinity, so we have 1 minus 5 over x over the square root of 4 plus with the 3 over x squared. So if we substitute 1 over infinity, we will have 0. So in here, we will obtain 0. In here, we will obtain 0. So we will have 1 over 2. So here, do remember, after we simplify, we have the negative. So here, we were approaching the value of y, which is negative 1 over 2. If you are new here, kindly consider subscribing to this channel and share this video to your friend. Thank you so much for watching this video. Bye.